Hi everyone. A recent Catchpoint survey identified that 66% of organizations use 2 to 5 monitoring or observability tools. And it also identified that 24% of organizations have breached a contractual service level agreement obligation during last 12 months. Those are two very important numbers. Having more than 2 to 3 or more than 2 observable tool is a little problematic because you will struggle to identify a unified, a single truth state. And the 24% number about contractual failures are alarming as well. What it shows is even with multiple tools, the organizations are struggling. My name is Indika Wimalasuriya. Welcome to Platform Engineering 2024. My presentation is based out of AWS Observability as Code, and I will focus on leveraging Datadog to enable advanced platform engineering. As part of my presentation, I will provide you a quick overview of challenges faced in the modern day observability platforms due to distributed nature. And we will quickly discuss about role of observability in platform engineering. And we will touch about Datadog, which I will be using to enable observability as code in AWS-based infrastructures. And we will look at how we can enable or implement observability as solutions, real-world implementation details. And we will wrap it up with some of the best practices and pitfalls you may need to avoid. So quick intro about myself. My name is Indika Wimalasuriya. I'm based out of Colombo. I live with my daughter and wife. I'm coming from a very strong reliability engineering and solution architect background. My specialties are site reliability engineering, observability, AI ops, and generative AI. I'm currently employed at Virtusa. I oversee technical delivery and capability development. I'm a very passionate technical trainer and an energetic technical blogger. I am AWS community builder, part of cloud operations, and also an ambassador at DevOps Institute. So to start, the distributed systems and modern day systems are evolving fast, and with that, it's also increasing the complexities we need to manage. The traditional monolith systems have already moved into microservices, and on-premise data centers which we use to host our applications, we now move into cloud. And some instance we move from cloud to the serverless architecture as well. So what this has done is there's an expansion of data sources, surging data volume, and exponential rise in failure scenarios. So while it's good and while it adds a lot of value in modern day systems, it has bringing in certain level of increased failure scenarios as well. So which resulted in difficulties in managing these environments, and also it has increased the role of observability. So the traditional monitoring, which was mainly rule-based, predefined approach of looking at systems, are no longer enough. We have moved into observability, and that's mainly due to distributed systems complexities, dynamic nature, and elasticity. And most of our systems are now container-based. We have CI/CD deployments, integrations. We are connecting to API gateways, and there's an increased in cloud service providers. Some of the systems are in polycloud, multi-cloud, leveraging multi-vendor solutions. And our systems have scalability challenges, which sometimes we are using these cloud service provider solutions to rectify. And this requires observability into these scalability triggers. And we would like to detect things much faster, resolve things much faster, and we want to have an end-to-end visibility of the user journeys. So these are some of the key things which is increasing or which result the need for observability. So if I quickly touch upon observability about logs are the what is your code is doing. We typically use logs for our root cause understanding. And we have metrics. Metrics are nothing but numbers, a point in time performance of your application. And metrics are generally used for alerting because it's a number. It's a good way of allowing us to generate our alerts. And we have tracing. Tracing is what is your code is doing at snap point. You can see what that code is doing, method level, the time taken, and even you can trace a request from a front-end request to middleware to the back-end, which is database calls. So tracing is very important. It's allowing us to understand or to time taken in our code, and it's allowing us to see what is our code is doing. And on top of that, we are building alarms, which are our monitors. We are developing a lot of dashboards. We are coming up with synthetic monitors. We are looking at real user monitoring, which is trying to understand what is your actual end users are doing. We are looking at the infrastructure. We are looking at the network. We are looking at the security aspects of our ecosystem. And obviously, we are looking at how we can optimize cost, the infrastructure cost, or AWS or the cloud provider, and other costs as well. So pretty much these are the key fundamentals when it comes to observability, which you want to achieve. So when it comes to platform engineering, I would like to take one example. Let's say you have one organization which is having around 3 departments or line of businesses, and each department have multiple applications or engagements running. And sometimes what can happen is that these engagements or the application teams may find their own comfortable observability tool-based solutions and observability tools, alerting tools, log management tools, security aspect. So they will start leveraging things they prefer. So what this happens is over a period of time, we are losing the unification, the unified approach. It's very difficult to enable consistencies. It's very difficult to build consistencies across these systems, and it's difficult to, when new applications and new services are coming in, we are having trouble and challenges. So as part of platform engineering, what we are trying to do into this specific area of observability is we want to build a unified observability strategy, which is to make observability consistent across teams and ensure that there's a centralized observability. And we want to build efficient troubleshooting and incident response framework, leveraging cross-team collaborations, which will derive fast and efficient root cause analysis. And we also want to ensure we have scalability and reliability, leveraging proactive monitoring, predictive capabilities, and other advanced features, and things like capacity planning. And we will also develop enhanced developer experience, because developers are important and they had to have the end-to-end visibility, observability into our production systems. So this allows us to, there's a need of us to build like self-service observability solution, access and dashboards specific to developers as well. And we will enable some services related to security and compliance and cost efficient and cost tracking and those things as well. So those are the key aspects or the key part of observability in platform engineering, and that will enable us to get the true value of platform engineering in observability area. And let me talk about Datadog, because here we are trying to use Datadog on top of that AWS and trying to see what capabilities of ability and observability as code solutions which we can enable. So here, if you look at it, we have multiple data sources. Like Datadog supports around 750 plus source integrations. It supports logs, traces, metrics, and metadata sessions as well. So it's also provide a lot of platform as services like dashboards, alerts, collaboration, mobile monitoring, workflows, Watchdog, which is its own AI platform, and also integration into OpenTelemetry. So some of the use cases, observability use cases, Datadog is providing infrastructure monitoring, application performance monitoring, unified universal monitoring, log management, the continuous integration visibility, continuous profiling, real user monitoring, network monitoring, synthetic monitoring, cloud security, application security, observability pipeline, and many more. So all of this allowed the key partners or the teams like development teams, IT operations teams, security team, support team, and business to have a full view of our ecosystem. So when you are building a AWS based observability driven platform engineering solution, there are a few things we need to be focused. So one is our centralized Datadog integration. So if it is the standard workloads, we might have to integrate, example for EC2s, the agents as well. And if it is containers, then we'll have to do the integration as well. If it is tools like AWS Lambdas, we might have to intercept the Lambda, the libraries, and then enable this AWS integration, especially for APM. And then with this, what we are trying to do is enable the key aspects or the elements of observability, which is about enabling the standard metrics and the dashboards and logs, which we want to make sure it's consistent, and also the traces, the spans, and those things, so that we can troubleshoot and identify what's happening at microservices hosted in AWS or in the containers or even AWS Lambda as well. So on top of that, Datadog allows us to develop alerting and incident workloads. And also there are other services like looking at the performance and scalability, resource management, cost management, and our CI/CD integrations, and looking at things like automated setup, and looking at the governance, how we can build different access controls, and how we can enable compliance control, and other developer related services such as developer access, documentations, and trainings. So those will allow us to develop a comprehensive observability platform engineering framework for AWS. So moving on. So when you look at observability as code, so there are key elements. One is treat your observability configuration as codes, which is about agent integrations or integration with Datadog in AWS, looking at metrics, logs, and traces, and how you can set up them with AWS-based ecosystem, and how we can leverage Datadog to achieve those things. And next one is about versioning and management. We want to do versioning control. We can use the components like Git, so which is allowing us to do version control and tracking of changes and to increase the collaborations. Of course, the observability as code solutions we will have to enable with CI/CD related deployments, automations, so that way we can, while the development teams are developing these solutions, they can push all these the observability as code solutions into multiple pre-live environments. From there, we can start deploying and until we deploy it into production. So this we can enable consistency and standardization, implement standardized templates, come up with some quality gates, and we can come up with modules for observability configuration and apply some consistent settings across multiple environments. And this will enable us to do a comprehensive observability, monitoring, and maintenance, conduct reviews, validations of our configuration, implementing test frameworks, and to ensure that we have a proper quality gates as when we are moving from our pre-live to the production environment. And also we can have standardization in documentation, and this will allow a lot of collaborations with multiple teams. And the whole idea is that we will not touch Datadog, but we will develop our solutions as observability as code, and these codes can be moved from one environment to one environment until we move into production, and different teams can contribute this. We can do the version tracking, we can enable the collaboration, and we can have better quality as well. So moving on, some of the benefits of observability as code solution when you are thinking of AWS is it will improve accuracy. There's an enhanced visibility because you are working as code, and because of that visibility drives a lot of accuracy. So it's code, you can do a lot of validations, and enable a lot of collaborations as well. And while we enable a lot of collaborations, we can build a lot of quality gates on top of our code, and it's much faster. So we can have much faster turnaround time. It can be consistent across environments. So that's one of our challenge. We may lack observability when it comes to the consistency in environments. Example, you may have some degree of observability in your production environment, but it might not be identical in your lower environment. And what that happens, developers will have challenge, and even there can be misunderstanding, misinterpretations, and there can be some challenges in achieving what we try to achieve. And obviously, observability as code promote better collaboration, and it's allow us to do continuous improvements in our systems. So moving on, with AWS, there are a lot of observability as code tools which we can use, things like Terraform, Ansible, Jeff, Pulumi, or AWS CloudFormation as well. And this instance, we are going to leverage Terraform, which is widely being used across the board. And what we are trying to achieve is we want to write entire our observability as code solutions using Terraform and then ship push into Datadog. And what we are trying to achieve is we want to create things like enable the Datadog integration, so we can completely automate AWS and Datadog integration using Terraform. And we want to ship these logs into AWS based logs into Terraform. Either it's your EC2s, the workloads, or the container based workloads, or your serverless framework. So all of those things we can ship to Datadog, and we can streamline that using Terraform, and enabling APM in your containers or the EC2 based workloads, or even in your serverless based frameworks. We can leverage observability as code solutions. And then we want to build common metrics and enable common metrics and develop common dashboards. So this is very important because generally the developers and the DevOps teams, SREs, they will refer some of these standard dashboards. And what we can do is, it's not just these standard dashboards are available in your production, but you can enable those in different your pre-live environments as well. Example, test and development environment, test environment, into an integration environments, staging environment. So this way you can have unification, and developers are able to look at things, and before they are trying to see how their code is going to behave in production, they have the ability of trying to understand how things are behaving in the pre-live environments as well. And then we can automate the synthetic monitoring creation, the synthetic monitors. This is very important. This is about creating production end user and mimicking them and what the actual end users are doing. So that way we have more control of trying to see how our application is behaving. And we can of course generate a lot of alerts on top of these synthetic monitors or the metrics or some of these log events as well. And we can automate the entire account creation, the access control in as observability as code. We can enable the CI/CD pipeline integrations, and in some instances, the distributed staging setup as well. And one of the important aspects when it comes to site reliability engineering is define your service level indicators and define your service level objectives. Datadog as an observability tool is providing a very good capability of defining service level objectives. You can either create with your good events divided by total, or you can create SLOs based on your synthetic monitors, based on to monitor uptime and things like that, or you can have SLOs based on different time slices as well. So all of these options which Datadog is providing, you can automate, you can we can get our developers to write SLOs and write it using observability as code solutions, and that can be navigated through multiple pre-production environments until it move into production. So that way we can enable consistency across service level objectives from pre-live environment to the production environment. We are obviously able to use automated incident management workflows, enable that using our observability as code solutions, and finally our compliance and governance control as well. So what we will do is we will look at some of the code snippets of how we can do some of the Terraform code snippets. So that will give you some idea about these integrations. So if I take a step back, so if I want to define or develop the observability as a code solution, leveraging Datadog for AWS. So what we will do is the step one is we have to define our observability configuration. What we'll generally do is we'll identify and create configuration files covering the key observability components such as metrics, logs and traces, dashboards, events, and most of the things I have covered part of the previous slide. And we will look at version control. We can have the observability as code, our code in Git, and then we can manage the versioning. We can enable collaboration, we can enable branching, and we can follow merging strategies. So that way that we can have more comprehensive control of our observability as code solution. And we can build a lot of test solution as well, the unit testing and other form of validations such as syntax and other validations as well. And we have to then, the fourth step is to enable this with the continuous integration, integrate with the CI pipelines, enable it automatically run test on to ensure these things go through multiple environments before we move into production. So we can have multiple quality gates. And part of before CI, you can do the automated deployments as well. And then we'll have to build the monitoring and validation, monitor the automated deployments moving across multiple instances, and then validation process. We can involve multiple teams who are owning these pre-live environments, like the developers, the testers, the into end-to-end teams and end-to-end integration teams, and even the DevOps and SRE teams. So they can go through this observability as code solutions, those outputs in multiple environments, pre-live environments for continuous review and validations. So this will typically enable your maintenance and compliance as well. So if you look, because this we are trying to focus on Terraform. So this is a typical Terraform folder structure. So you will have your observability as code, the folder, and then we'll have the deployments. You will have main TF and your providers, which will enable you to do the provider configuration with Datadogs. You can define your variables and you can version your Terraform as well. And then you can have a set of your the YAML files which are looking at your creating monitors, service level objectives, dashboards, creating maintenance windows, or the other integrations, the form of automations which you want to enable. So if you look at typically, if you want to integrate the Datadog, what we'll have to do is we'll have to enable Datadog agent running in your workloads, or we can do a direct integration with our serverless framework as well. So here we can use Terraform to do this configuration. So you can see we are using Datadog APIs and other keys. So you don't have to actually, what we can do is we can use AWS Secret Manager, and then we can read this keys part of reading Secret Manager, so that we have a better mechanism of handling secret keys as well. And we are able to some of our the logs in AWS, which is typically reside in CloudWatch, and then we can ship these logs into Datadog. And while doing that, we can do a lot of regular expression. We can leverage them to split our logs and then send some of those important logs. And we can filter logs based on the log type, like it's on the error or the warnings or likewise. So, or we can extract some of these different log exceptions and send. So we have a lot of exceptions. So we have to be mindful that Datadog is a paid solution, and it can be sometimes a little expensive when we are using a lot of log related, when you are trying to ship the entire log into Datadog. So what you can do is you can use a lot of filtering, so that way that you can save some of the cost when it comes to using Datadog for log management. Moving on. So one of the other important things which I personally like is develop a lot of synthetic monitors. So we can develop a lot of synthetic monitors to test different pages or some of user journeys, and we can provide some the failure, the retries. And here again, those are very important things. So the synthetic monitors will actually try to mimic actual end user in our production systems. So it has a lot of value, and so we can again use Terraform to get this done. And one thing personal of my favorite is creating alerts. So we'll have to create alerts based on it's about service level objective based alerts based on your caching layer, alerts based on your the middle layer, the logic layer, the service layer, and you have to create some of these alerts based on your other end-to-end journeys as well. So it's so what you have to do is your alert has to be more or less correlated with service level objectives. Service level objectives will correlate with end user experience. And you can, of course, have a lot of triggers when it related to infrastructure monitoring, network monitoring, and other anomaly monitoring as well. Alert can be standard, the metric-driven alerts, or you can enable some of the alerts like AI capabilities like anomaly-related alerts or forecasting. And then alerts, you can define what are the thresholds, or you can let, in case of anomaly detection and forecast anomaly detection especially, let Datadog handle those things, the thresholds, diamond thresholds based on baseline. So you can configure what are the teams these alerts has to go through, and you can come up with a lot of tagging. So the using observability as code solution in AWS in this area, that will provide you a lot of options, lot of standardizations, and that will add a lot of value in a large organization managing multiple teams. And then most of the teams, assuming they use some workloads like EC2, so the containers, or they are using serverless-based solutions like Lambdas, and pretty much sometimes what you monitor might be same. It your caching metrics, the service layer related metrics, which are the backend related metrics, front end related metrics if you enable real user monitoring. So there can be a lot of common metrics, and on top of that we can develop a lot of common dashboards as well, which can be aligned, which can be even cater into multiple different end user journeys, because the technology is same, the what's happening at the background is same. So we can create some of these very standard dashboards. So these dashboards can, using observability as code solution, we can move in different environments in AWS, like your pre-live, the staging or production. So that way you have a lot of consistency. You allow your developers to go and look at how the application is behaving in multiple environments, not only in production. So this is a very value added thing. And with this, we can make it a lot of standardization. So whenever the same capabilities, we can allow other engagements, other teams use as well. So whenever new applications, new engagements are getting onboarded, things will be very straightforward. They can just simply plug into the Git, look at these terraform scripts, observability as code solutions, and then integrate these in their AWS environment. So moving on, one of the other thing is enabling APM, application performance monitoring. Here again, if it's like the workload base, or using open telemetry or serverless blade, integrating APM with your serverless frameworks, we can leverage observability as code solutions in AWS as well. And finally, some of the platform engineering typical use cases are account creation, access control, and we can use observability as code solution here in AWS. What we can do is we can have different access layers for your dashboards, to the monitors, your logs, synthetic ability to create the admin users, read-write privileges, account creations, cost views, and all of those things. So we can leverage Terraform and which mean your observability as code solutions with AWS, leveraging Datadog to achieve these capabilities. And finally, of course, like we can use this to streamline our CI/CD pipeline integrations using Terraform. So this will be very beneficial because we want to ensure this observability as code solution goes through multiple environments so that we can take this benefit. And in case if required, there's a specific customization needed for your distributed tracing setup, we can leverage this as well. And as I said, one of the other important thing is defining service level objectives. And sometimes we have seen there's a common framework, common aspects when we are defining, because in the typical organizations, we are using some of these, the AWS based workloads, the containers and serverless frameworks. And that enable us to leverage some of these standardizations and the common factors. So using SLO as code, what we want is, instead of defining SLOs at last or developing SLOs as once the application goes live, we want our developer community to think about SLO, service level objectives, when they are designing, developing, testing, and deploying their code into multiple environments. So they can write the SLO as part of your code and then ship and let it go through multiple environments until production, even to at production. So that way that we can monitor our service level objectives, and even example in one of our pre-live environment, we can do performance testing, we can do soft testing, we can do security testing, we can do other form of stress testing, and we can see how our SLOs are behaving. We can mimic some of high peak traffic, the high concurrent traffic, and simulate some of the everyday or spike or the flood of traffics and different type of user behaviors, and we can see how our SLOs are behaving. So this is a very powerful feature. So typically what happened was people define SLOs in Datadog for AWS based ecosystems at large stage for production, but this way from the very beginning in multiple environments from the start we can do that, so that there's a lot of visibility, focus, consistency, and we can achieve a lot of good things by doing this. And obviously Datadog provides, whenever there are events created, we can invoke some webhooks, and from there we can invoke some remediation engines running in our AWS workloads or serverless framework like Lambdas. With that, we can do a lot of self-healing. We can build a lot of self-healing solutions. We can do a lot of automation solutions. So observability as code is providing those capabilities as well. And then we can, of course, build our compliance and governance control based out of this observability as code solution. And finally, in case whenever we have any scheduled deployments, scheduled downtimes, or downtime related to backend teams, which will have an impact on some of our monitors, we can enable maintenance windows, or whenever there's CI/CD deployment, unless if you are using like a very sophisticated deployment strategy, you are calling out a certain level of outage, you can create your maintenance windows as observability as code, and then you can suppress your traps. So you can integrate that part of the release CI/CD pipelines, so that way you can test it as well. And whenever you are doing this production deployment, automatically pipeline will enable the maintenance window, which is suppressing your relevant traps during that particular deployment window. And after that, you can enable it and do a testing as well. So this whole aspect, instead of doing manually, you can leverage the observability as code solutions in AWS to achieve this thing. So moving on. So those are some of the things which we can do as part of observability as code, which will support our ultimate goal of developing a comprehensive observability related components, service as things when it comes to platform engineering. So while you're doing this, I think it's very important for you to be mindful of typical issues and ensure that you are ready for that. And one of the key issues is whatever we do these days, we have to ensure that we have a way to measure progress and whether what we have done is actually allowing business to see some benefits. So we had to look at your mean time for detection, mean time for resolution, mean time for between failures. So we have to ensure that there's a way for we can extract these metrics so that we can measure this when we are going through our observability as code journey in AWS. And we had to look at whether this is helping us to improve reliability, availability, and how this is helping us to enhance the customer experience. So this can be tagged into your service level objectives. Can you improve your service level objectives in a periodic fashion? So those are some of these values we have to bringing in part of these kind of solutions. And also, can you improve your developer velocity? Can this have more positive impact on your DORA metrics, which is like lead time for change, increasing the change frequency, make your production volatile, while you manage your customer experience using service level objectives and reduce the deployment failure rate and those things. So you had to think about those things and capturing those metrics, and some aspects of this you can of course use observability as code solutions as well. So this you can, instead of letting teams coming up with their own solutions, you can make this standard, make it also observability as code solution. So that way this can be tracked properly as well. And finally, before we wrap up, so observability as code has a lot of advantages, but there are some best practices you have to be mindful. So number one, I would suggest is managing your secure API keys. So when it comes to Datadog integration using AWS, you will have to look at, there can be your Datadog API keys and AWS based credentials. So those you will have to leverage and access in a very secure way. And you'll have to definitely use version control, because that's one of the key elements bringing in observability as code. So think about, ensure you don't miss out and you do the version control, keep your code in a Git, and those are best practices. And obviously you will have to do a modularization instead of, going a big band way. Modularize it to your agent Datadog integrations, APM enable, real user monitoring enables, metric enablement, dashboard creation, monitors, synthetic monitors, log pipelines, governance, access controls. So that way there's modularization so that you can take those advantage. And this observability as code solution has to be plugging with your deployment pipelines. It has to go through multiple environments and until you move into production. So that this way you can take the true potential of this observability being written as code for AWS. And you'll have to look at role-based access controls, enable them based on your user community. You'll have to look at how you do that as well. And this has to be a centralized solution. So this should provide centralized output, centralized dashboards, centralized the alerting mechanisms, centralized logging systems, standardization across everything. That is very important. So this has to result in standardization. So every engagement, every line of business, every team in your organizations are pretty much following a defined and standardization with quality gates and with the ability to review and improve continuously. So this should come up with lot of documentations, reviews, so that will enable collaboration. And Datadog has a lot of integrations. Sometimes leveraging those direct integrations will save your time when it comes to AWS, like serverless integration, container integration, and with other different AWS service integration as well. So all of this is driving collaboration. So you had to ensure that this taken into your multiple teams and work with them to enable this collaboration so that you can get this value out of this, enabling observability as code for your AWS ecosystems. With that, I would like to close my presentation. I hope you enjoy it, and we'll see you in another future presentation. So thank you very much for taking your time. And there are great amount of presentations done by different presenters, part of Platform Engineering 2024 organized by Conf42. I am requesting everyone to look at these presentations as well. So thanks for taking time. Take care. Bye.